right, let's talk about reciprocal, quotient, and Pythagorean identities. We actually talked about these in the beginning of the year, remember? Many of you guys forgot about them. They felt left out. So since they felt so left out, I decided let's go over them again. Okay, so we have 11 trig identities to know and not memorize. What the heck? Not memorize, but understand and love. Okay, what is the reciprocal of each of the following? I'm not going to put an equal sign because they're not equal. Reciprocal of 2 is awesome sauce, 1/2. The reciprocal of 3/4 is 1/3/4, which simplifies to, very good, 4/3. All right, we know reciprocals. Reciprocal identities in terms of trig functions. So we have, we have a few of these. So we know that sine of theta is equal to 1/cosecant of theta. And we know cosine of theta is 1/secant of theta. Can you figure out the remaining ones? Write them down. Put me on pause. I'll have them up here. All right, bada boom, bada bang. Here we go. Check your answers. Hopefully you have the same thing. We probably already know this. Maybe we think of this as just being like, oh, I just know what cosecant of theta is, but it has a special name to it, which is called an identity, which makes it 10 times more important. What does the word quotient mean? Quotient. 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 Oh, quotient, by the way. It is the result of division. There's a lot of people in this world that don't know that, so now you do. Okay, next question. How do sine, cosine, and tangent relate to the coordinates of the unit circle? We already talked about this. Write down your answer. All right, so using this, we have two quotient identities. One involves the tangent of theta, which is, we know, as sine over cosine of theta. The other quotient identity has to do with cotangent of theta, which is cosine of theta over sine of theta. Quotient, the result of division. What is the Pythagorean theorem? Oh my goodness, this is so easy. A squared plus b squared equals c squared. Favorite theorem, Pythagoras, you were so good job. All right. Also, just want you to keep in mind that this does not imply that a plus b equals c. A squared plus b squared equals c squared. Okay, makes it those are squared. Now, how do sine and cosine relate to the sides of a triangle? This is actually what we talked about in our previous lesson. We know that sine is the opposite over hypotenuse. We know that cosine is the adjacent over the hypotenuse. So now let's blow your minds right now with something amazing. Let's say that we have a right triangle. Hypotenuse, opposite, adjacent. Okay, beautiful. All right, if we were using our Pythagorean theorem, stay. Okay, oh my goodness. Stay. Okay, good. We know that that would be a squared plus b squared equals c squared, or in this case, that's opposite squared plus adjacent squared equals hypotenuse squared. Let's say I want this in terms of opposite over hypotenuse and adjacent over hypotenuse. So I'm going to go ahead and divide everything by hypotenuse squared. Well, what does that equal? Well, opposite squared over hypotenuse squared is, well, that's sine squared. And adjacent over hypotenuse, both of them being squared, would be cosine squared of theta. And this over here is just 1. What? That's beautiful. So that actually is our first Pythagorean identity, which we all know. This one's pretty, we're pretty familiar with this one, which is a nice thing. Also, just a side note here that I want us to remember that sine squared of theta is sine of theta quantity squared. Why don't we write it as just sine of theta squared? Because this is only squaring the theta, right? And we want it to be sine of theta quantity squared. Okay, so this is just one of our Pythagorean identities. We can actually use this to come up with our second one. I'm going to just box this so you remember that that's what that is. So let's take this and divide everything by sine squared of theta. Okay, well, sine squared of theta over sine squared of theta is just 1. Cosine squared of theta over sine squared of theta is not tangent, but cotangent squared of theta. And then 1 over sine squared of theta is cosecant squared of theta. These are getting so cool. But there's more. Okay, the last one. Sorry if I'm getting annoying. Let's go back to our sine squared of theta plus cosine squared of theta equals 1. Instead of dividing by sine squared of theta, let's divide by cosine squared of theta this time. Sine squared of theta over cosine squared of theta is, very, very good, tangent squared of theta. This is 1 equals 1 over cosine squared of theta is secant squared of theta. Giving us our 3 important Pythagorean identities. Key thing here is, let's not think of this like we have to memorize them. Key thing is that we understand them. And obviously, you know, if I know this one, which it's pretty simple to remember, I think most of us do know this one, we know how to derive the others now, right? So if any time you're asked to do these, you could just derive them. All right, in conclusion, so to the ka to the toa, again, we have 6 reciprocal, 2 quotient, and 3 Pythagorean identities.